Hello everyone and welcome back to another video. In this video I want to talk a little bit about my goals and why I started this channel, and then I will show a project, a very simple project at the end of this. It's nothing too complex, it's rather simple, but it's kind of cool. I'm creating a space to think out loud about computer science, code, and the systems that run our digital world, all while layering in gameplay that gives it rhythm, relatability, and sometimes some chaos. I'll be screen recording games in the background, and over it, I'll be talking about the things that matter most in the world of tech. The nature of computation, the design of real systems, and what it means to build things with clarity and control. I've always believed computer science is less about writing code and more about writing logic for the real world. Every line of code is a formal negotiation between what the hardware is capable of and what the software is trying to express. So on this channel, I'll be diving deep into that. Data structures, memory hierarchies, caching patterns, OS level concurrency, and what makes one algorithm just good enough and another truly optimal. I'll talk about CPU pipelines, instruction level parallelism, GPU rasterization pipelines, and how things like cache coherence, SIMD registers, and thread scheduling matter just as much as your choice of programming language. You'll hear me talk about L1, L2, L3 cache interactions, CPU core affinity, NUMA awareness, not in theory, but in how they manifest in real applications and games. Most of my core systems programming is in Rust, not because it's fashionable, but because it makes sense to me. Rust is one of the few languages where I can feel the boundaries between syntax and semantics tighten. Uh, It forces me to think like the machine does in lifetimes and ownership and explicit data flow. Rust's borrow checker isn't just a compiler feature, it's more of a complex tool that teaches discipline. Every time you fight it, it's usually because you are trying to write something risky. Rust slows you down just enough to make your code correct. I'll talk about how traits provide zero cost abstraction through monomorphization, how option and result enforce control flow that C++ would let silently decay, the elegance of match statements and algebraic data types, how lifetimes are more than syntax, they are contracts that live in the type system, and why Rust's async model uses a polling-based executor and why it avoids green threads in favor of explicit control of concurrency. I'll talk about how Cargo and Crates.io, from one of the most literate consistent dependency ecosystems I've ever worked with, period. I'll even peek into the MIR, or mid-level intermediate representation, the stage between Rust source and LLVMIR, to understand how decisions and code become optimization opportunities in the backend. I work on a wide spectrum of projects, most of which live somewhere between theory and engineering. You'll see low-level systems, monitors written in Rust and C++ that tap directly into hardware counters, um, full-stack MERN and PERN apps with deeply considered data models, REST and GraphQL endpoints, JWT auth flows, and state management tuned for performance. Kotlin-based experiments. I'm still very new to Kotlin, but you'll see a lot of that in multi-platform app delivery. Python tools for automating, workflows and analyzing logs with pandas and matplotlib. Ruby experiments for rapid prototyping and DSL design, and maybe even some emulation level stuff, perhaps game engines or CPU, GPU simulators for the curious mind. The gameplay footage you'll see isn't just for aesthetics, it's a metaphor. Games are systems, input states, event loops, collision detection. These are just live demos of applied computer science. Watching a game render a frame is watching the GPU handle thousands of parallel shader executions across pipeline stages, vertex shading, fragment interpolation, screen space ambient occlusion, and post-processing. I'll occasionally dig into what that means, how Vulkan and DirectX APIs control draw calls, how frame pacing and vsync affect perceived latency, and how physics engines simulate rigid bodies with numerical integration, and how AI pathfinding uses uses a I cannot remember it's how D I can't remember how to pronounce this. It's DIJKSTRA, or even reinforcement learning models under the hood. Um, so and because we live in the world of AI, I'll definitely be talking a lot about AI. I really like UX, or user experience. That's huge to me. So I'll also explore topics like how AI models interact with systems, not just the training, but deployment, latency, optimization, and quantization. How user experience, or UX, is as much a system of incentives as it is of buttons and pixels. The psychological load of poorly designed software, and how developers can build for flow, focus, and feedback. So, in summary, this channel is where I combine three things I'm passionate about: talking about real computer science from code to circuits, playing and analyzing video games as live systems, and sharing the joy of building things that work, not just for the sake of code, but because it means something. Um, I'm excited to continue on with this channel. The video I'm going to show you, the video demonstration of this project I'm going to show you, is coming up now. All right, so here I am in Visual Studio Code. This is let's talk about this for a little bit here, just real briefly. So what I've built here is it's a real-time system monitor dashboard. It's very simple. It really is. So I'm not going to talk too much on this. This is a real-time monitoring. You can see CPU usage, live monitoring with historical charts and multi-core detection. You have memory usage, real-time RAM and swap monitoring with trend visualization, process management, live process lists sorted by CPU usage with memory details. There's disk usage. There's a comprehensive disk space monitoring for all mounted drives, network statistics, and interface level network traffic and packet monitoring, system information, uptime, load averages, and process counts, so on and so forth. The UI is very simple. This was built entirely in Rust, so let's just get into it here. I'm gonna cargo run, spin this up. And there it is. It's really very simple. You can see the CPU usage, memory history. You can see this is all in real time. Here's your uptime, processes, disk usage. It's all here. I can do, here's the processes. So I can go back to 1 for the overview and go back to processes. There it goes. I'm going to go to network, and I integrated a help, but that's not important. So there it is. It's real simple. Let me go back to processes, and it's working in real time. There's the overview. Here's what it looks like in VS Code. It was not a very difficult project. It was fairly easy to do, but it was fun. So that concludes this video. I just wanted to talk a bit about what my goals are for this channel, and I can say this, that in the future there's going to be a lot more video gameplay. You know how YouTube channels tend to evolve over time, but I want to stick to the core, computer science and video games, as mentioned before. But thank you for stopping by. We'll see you in the next one. See ya.